So welcome to the 2022 Environmental Policy Lecture. My name is Curtis Rollins. I'm president of the Western Australia branch of the Australasian Agricultural and Resource Economics Society, which is more easily referred to as ARES. And I'm also a PhD student at the University of Western Australia. So I'll be facilitating this event today. So while this is a virtual event, the UWA, David, and I are all in the Perth region, so I'd like to begin by acknowledging the traditional owners of the land on which we meet today, the Whadjuk Noongar people, and to pay my respects to their elders, past and present. So this lecture is an initiative of the WA branch of ARES, the UWA Centre for Environmental Economics and Policy, of which Dave is a co-director, and the UWA Centre for Agricultural Economics and Development. So each year we invite a leading national or international speaker to discuss important environmental or natural resource issues. And this event gives us an opportunity to deliver an interesting lecture on a topical issue to our members, but also to engage with a wide variety of people from outside of our usual group. So I see there's a lot of people joining us from across Australia today and also from around the world. So I thank you all for being here. So this year's lecture will be delivered by Dr. David Pannell. David is a professor of agricultural and resource economics at the UWA, and his research includes projects on the economics of agricultural production, on farmers' adoption of new practices, and on the analysis of agri-environmental policies. So this includes a wide variety of work related to climate, soils, and farming systems. So in my personal opinion, I think Dave is probably one of Australia's most significant agricultural and resource economists of all time. And I think this is backed up by more people than just me. A recent assessment, international assessment, ranked him as Australia's top researcher in the field of agricultural economics and policy. He's also been named a Distinguished Fellow of ARES, and he's a Fellow of the Academy of Social Sciences in Australia. So on top of his excellent academic research record, Dave also does a great job of ensuring his work and experience are useful to those outside of our academic bubble. He provides quite a lot to our community by delivering seminars just like this one. He regularly discusses important environmental and agricultural issues on his blog, which is called Pannell Discussions. He's developed a really successful online public course in agricultural and environmental economics that's been taken by thousands of people. And he's recently started offering a course in cost-benefit analysis that's open to people outside of our university, which it's been really well received so far. And if you're interested, I'd recommend that you check that out too. So David also regularly works with government agencies, NGOs, agricultural consultants, farmers, and natural resource managers to help them answer their research questions in a really practical manner. And this has led him to develop numerous tools to help these people and groups make environmental and technology adoption decisions. And these tools are also very heavily used and quite popular. So with that, I'd like to hand it over to David for this lecture. Thanks again for agreeing to do this, David.
So thanks very much for the introduction, Curtis. I want to start by acknowledging my co-author, who is, let me try and get this to work. There we go. Who is Michael Crawford from the CRC for High Performance Soils. So Michael and I wrote a paper that was published just a couple of weeks ago in the Farm Policy Journal. And a fair bit of what I talk about today will be drawn from that article, but not all of it. I will be going beyond the material in the article in various points. And I wanted to stress that when I do that, I'm not speaking for Michael, I'm speaking for myself. Well, we've got a big crowd registered for today and a good lot of people online. So you don't need me to tell you that soil carbon sequestration is a topical issue. It's part of Australia's plan to reduce emissions to address climate change. And in last year's report, called the Emissions Reduction Plan, it says that landholders could earn around $400 million in additional revenue through the sale of accredited soil carbon sequestration in 2050. In a previous document, the year before that, called the Technology Investment Roadmap, soil carbon featured again. This time, there's an initiative to invest in reducing the cost of measuring soil carbon, which they say is about $30 per hectare per year currently, to under $3. They say this is a stretch target, but they're going to try and do that to try and enhance the uptake of and enrolment in the program. And in December last year, the government released a new method for soil carbon. So a method is basically a piece of legislation that describes the rules and constraints and circumstances under which farmers can qualify for payments under the scheme. What do they have to do to earn money? So you can see there's a lot going on in the government space. The government considers soil carbon to be one of its most important, or a significant part of its overall efforts to address climate change. They're not the only ones who are interested. Ross Garnaut is very positive about it. Ross is probably Australia's best known economist. And in his recent book about climate change, he said Australia can make an exceptional contribution to climate action by creating natural systems to store more carbon in soils. At the same time, and I guess in response to the government policy, there's a growing support industry, various companies setting up to bridge between farmers and the program to support farmers and help them and take measurements for them. There's a lot of media coverage covering all different aspects of the issue. And so from all that, a farmer might be tempted to think that this could be quite an easy way to earn some money. All they need to do is measure their current level of soil carbon, adopt one of the 13 eligible practices, then measure the increase in soil carbon, tell the government about it, and wait for the cheque. However, it's not quite as rosy, potentially, as that sounds. There have been quite a few experts in the area, soil scientists and others, coming out and expressing reservations about the potential for soil carbon to be increased and or to contribute to climate change mitigation. And the program itself has had limited uptake, low participation so far. So since the program started at the end of 2014, there have only been 177 soil carbon projects registered on the Emissions Reduction Fund project register, which is a public database that you can access. So that's not very many. That's only 1 in 500 farmers. So that's basically an expression of interest in doing a project by farmers. And of those, only 5 projects have actually been contracted. And I understand that only 1 has been awarded carbon credits. I couldn't actually see that in the register, but I've read that in a couple of places. So those last 2 slides flag that there are some challenges here. It's not a simple matter to make this program work. And so I'm going to start by talking through the various challenges that have been identified, and that includes technical challenges, economic challenges, challenges about information availability, and challenges about policy design. And then I'll try and address a couple of key questions, which are, can paying farmers to sequester carbon contribute to mitigation of climate change? And to the extent that it can, is it a cost-effective approach? All right, so let's get stuck into some of the challenges. The first one is really a technical challenge, and that is that the major drivers of carbon stocks in the soil are known to be rainfall and soil type. Management makes a difference, but it's a relatively minor contribution. I've read that it's sort of 90-10, 90 soil type and rainfall 10 management. And then 2 weeks ago, there was a workshop and someone said it's 95-5. So, it's clearly a relatively small contribution. And that's backed up by the fact that the measured gains in soil carbon in soils have mostly been pretty small. And I'll present some numbers later on that. And this was sort of brought home to me week before last when I got an email from a New South Wales cotton farmer who I've known for a long time in response to something that I'd written. And he made this comment: I tried and failed for 30 years on my farm to lift soil carbon levels. So this is a farmer I know quite well. He's a very serious, responsible, diligent farmer. He would have, and socially responsible, concerned about sustainability. So it really struck me that he hadn't succeeded. It's not to say that no one will succeed, but that was one example that illustrated how hard it can be. Another technical feature of soil carbon sequestration is that once a farmer changes their land management to a new practice that will promote sequestration, and let's suppose that it does, then what we find is that the soil carbon level converges on a new equilibrium level over the course of a few decades. So in this graph, you can see the sort of pattern of increase and then levelling off of the growth of soil carbon in the soil. What that means is that the level of new sequestration that's occurring year after year is actually falling over time. So we don't continue to get the same high level of sequestration that we start with. Then another couple of challenges that are explicitly built into the way that the program operates. One of these is the risk of reversal. So we know that if, for example, if there's a drought, then some of the carbon that has been sequestered over recent times can be lost back into the atmosphere. And the program does allow for that. It makes a deduction of 5% from the estimated level, from the measured level of soil carbon to account for that. Personally, I think that's fairly generous to farmers, but that's the actual system that's in place. And the other deduction of this type is a deduction for impermanence. So permanent sequestration in the climate change world is considered to be 100 years. It's as good as permanent. But in the Emissions Reduction Fund, which is the program we're talking about, most of the contracts are let at 25 years. And if a farmer opts to go for a 25-year period, then the level of payment that they receive gets scaled down by 20%. Again, to me, that feels like a fairly generous system for farmers. There's a 75% reduction in the time commitment, but only a 20% reduction in the payments. But nevertheless, that's the system that's currently in operation. Then another issue that farmers have to confront and deal with is the fact that the policy allows for deductions if there are increases in other emissions. So this, we expect that there'll be some increases in soil carbon, but there could also be, as a sort of a side effect of the practices that the farmers adopt, there could also be other increases in emissions. And so, for an example, one of the key changes, or key in the sense of one of the changes that's on the list of things that farmers can do, is to switch from permanent cropping to permanent pasture. That's probably the change that would result in the largest increase in soil carbon. So that's positive. But on that permanent pasture, we would expect farmers to run livestock. And from the livestock, we would have emissions of methane. And there has been research on how these two things stack up. So Mayer et al. 2020 published a paper where they estimated that the losses from increased methane roughly cancel out the gains from increased soil carbon sequestration. So that's pretty discouraging. Situation wouldn't be to that degree, to that extreme, in a situation where farmers are, so they're livestock farmers and they are trying to sequester carbon on pasture. And the way they're doing that involves an increase in pasture productivity. That could also result, and probably would result, in an increase in livestock numbers, but I would think to a lesser extent, and probably the gains wouldn't be fully cancelled out, but they would be cancelled to some degree. Then there is another potential increase in emissions of a different type. So if the farmers, even if the farmers don't switch over to livestock production and increase their emissions that way, higher soil carbon under a crop enhances the conversion of nitrogen fertiliser to nitrous oxide gas. And that's a concern because nitrous oxide is 300 times more potent than carbon dioxide per unit of gas. And so it doesn't take very much extra nitrous oxide to really make a dent in the gains that we've made. And again, there was a study that tried to weigh up the positives and the negatives in this situation. They looked at a range of different circumstances for croppers in New South Wales specifically, and they found that in only a few cases did the increase in soil carbon storage counter the nitrous oxide emissions sufficiently to provide net greenhouse gas abatement. So another significant challenge. Part of the problem in this case is that, as I showed earlier, the soil carbon sequestration decreases over time, but unfortunately the increased nitrous oxide emissions don't decrease over time in the same pattern. They sort of continue on at a more or less steady level, and so they sort of add up over time and eventually overtake, or can, if they're large enough, they can overtake the soil carbon sequestration level. Then there are some other costs, so some specific costs of being in the program. Of course, there's costs involved in just doing the paperwork. There's time involved that farmers would need to do themselves or pay someone to do. There's a cost involving in taking the measurements to establish a baseline level of carbon in the soil before they start to change their management. And then continuing on with that, there's a cost in measuring the soil carbon in a reasonably large number of spots on the farm over time. So they all come at a cost, and so that last one in particular I mentioned early on, there's efforts going on to reduce that cost. It's pretty high at the moment, about $30 a hectare, and hopes to get that down to about $3. For farmers who commit to the program, there's another cost that they need to think about, which is the cost of inflexibility. So if they commit to the program, they're committed to staying with the same practices for the duration. So if it's a 25-year period, they've got to stick with them for the full 25 years. That could be a problem if there's or they might come to regret that if there's major changes in markets or in technology down the track at some future time that make them wish that they could do something else. So that they might view that as a sort of a cost of inflexibility. And then another cost that's not a cost of being in the program, but could be a cost of adopting these carbon sequestering practices. And that relates to the fact that some of the carbon in soils is in the form of humus. It's different in different soils in different locations and so on. But to give you a feel, in West Australian soils, it's probably somewhere around 50% of the carbon is in the form of humus. And in some ways that's good. That's a relatively stable form of carbon in the soil. So from the perspective of a climate change mitigation approach, then that's good. It means that it's less likely to leak back into the atmosphere. But the problem is that the biological process of forming humus ties up other nutrients, particularly nitrogen, phosphorus, potassium and sulfur, that would otherwise be available to plants. And replacing these nutrients costs money if they're going to be replaced with fertiliser or some other means, or potentially the farmer doesn't replace them and has to deal with having a lower yield. Now let's put those various factors into perspective, starting with crops. We know that realistic levels of carbon sequestration in soils under crops range from about 0 up to about 0.7 tonnes of CO2 equivalent per hectare per year. And if we use a carbon price of $25 a tonne, which is the price used in the recent government reports, and we use the mid-range of 0.37 tonnes, then we end up with a potential payment of around $9 per hectare per year. This is quite small and really isn't going to motivate a lot of behaviour change by croppers. To get a perspective on how small it is, the pie chart on the right shows the small amount of payment for carbon versus the amount of income generated by selling grain for a 2.5 tonne wheat crop. So it really is quite small. But the influence of the program on farmers' behaviour is even less than that indicates, because we still have to subtract off the various costs and deductions that I've been talking about. We need to allow for the fact that sequestration falls over time. We need to allow for risk of reversal, the deduction for impermanence, the deduction for other emissions, the cost of measuring soil carbon, reporting and auditing and so on, the cost of inflexibility, the cost of tying up other nutrients have all got to be factored in. Potentially also the cost of doing the new practice. It might cost something to implement. And then to some degree, countering those, there could be benefits from adopting the new practice other than the payments for carbon sequestration. So improved soil condition, soil quality, more productive crops or pastures as a result. So a farmer would want to think about all of those things when weighing up whether to adopt the practice and sign up to the program. The bottom 3 points there are the costs and benefits to the farmer from adopting the practice separate from the ERF program payments. This is just looking at adopting the practice on its own. And then the top group are the benefits and costs of participating in the program on top of the benefits and costs of adopting the practice. So that's what I want to focus on, because that is what's really going to drive the decisions that farmers make about whether they want to join the program. So it's what determines how impactful the program is in countering climate change. This table shows a number of different scenarios where I'm bringing in numbers for the cost side now for that top group that are about benefits and costs of being in the program. This first column is the scenario I was just looking at, carbon at $25 a tonne, and the initial sequestration 0.37 tonnes per hectare per year. Then I've allowed for the fact that the average sequestration over the 25 years will only be about half of the initial level. I've got the standard deductions for reversal and impermanence. I've got a deduction for other emissions. This is not so clear what this should be. There's no standard deduction, but based on that paper that I cited earlier, I've gone with an assumption that nitrous oxide amounts to about 0.8 or 80% of the benefits from sequestration. So it doesn't counter all of them, but most of them. Then I've got a cost of soil measurement and reporting and so on. This is quite generous to the program. I've assumed that the cost of measurement has already fallen to $15, plus an extra $1 for the other things, and that it will fall to $3 by 2030. So I don't know whether that's true, but that's what I've assumed here. And I've got a nominal cost of inflexibility, just $1 a hectare, and farmers, depending on their perceptions, might think that that is or isn't enough. But bringing that set of numbers together, doing the calculations, I end up with a benefit of participating in the ERF of minus $4 per hectare per year. So farmers are actually worse off if they join the program than if they don't. If the price of carbon goes up to $50, nothing else changes, of course the benefits of participation go up a bit, but not dramatically. I've only gone up to -2, so it still doesn't look like a very attractive prospect. For pasture, things are a bit more positive. The rates of carbon sequestration would be higher. The sort of the mid-range rate that I've used here is 1.5 tonnes per hectare per year. I've got a slightly higher average sequestration relative to the initial level. I've got a lower level of deductions for other emissions. This 0.035 is picked to correspond to about 1 extra DSC of livestock being carried as a result of adopting the carbon sequestering practice. Some of them, in some situations, that might be too low. I've got the same cost of measurement and inflexibility, and that amounts to a positive number, but it's still only $7 per hectare per year. So still a small influence in the scheme of things. And pushing the carbon price up to $50, this time it does make a slightly bigger difference. So we've got $16 per hectare per year at the bottom there. It's still not a big number, but it is at least positive and would have some motivation for a small number of farmers. While we've got this table up, I want to highlight that lowering the cost of measurement, one of the previous government's key strategies, doesn't solve the problem of relatively low levels of net benefits from being in the program. Because in these numbers, I've already assumed that it does get lowered by 2030, and we still get relatively unattractive numbers, small in the scheme of things numbers for both crop and pasture. Of course, if price of carbon dioxide went even higher, which it could well do in the future, then the numbers particularly for pasture, would go up from here. So the implications for farmers from this are pretty strong. They say that most farmers shouldn't expect big money from the ERF for soil carbon, especially not croppers. I've played around with those numbers quite extensively, and I can't really find a scenario that makes it look worthwhile for croppers to commit. The prospects are slightly better for livestock producers, particularly livestock producers in high rainfall areas where the level of sequestration is likely to be higher. So they are the ones who could end up with the bigger numbers from that page before, but they are going to be a minority of farmers around the country. That's not especially surprising, and it's not at all inconsistent with what we know from surveys that have been conducted of farmers. So here is a survey that was conducted by researchers in my department here at UWA, looking at farmers' attitudes and perceptions about adoption of carbon farming practices. And just selecting one little quote out of their conclusion, they found that the opportunity to generate carbon credits was not an important driver to adopt carbon farming practices. The practices are most likely to be adopted as a result of the private benefits that they can provide. So that is not at all inconsistent with what we've just looked at. If farmers are going to adopt these practices at any scale, it's going to be because of the private benefits predominantly. All right. So those last couple of slides are very much focused on the issue from the perspective of farmers and how the idea of joining the program might look to them. Let me change tack now a little bit and look at it from the perspective of the society in general, more broadly, and think about it as, well, is this a sensible strategy to be part of a policy to address climate change? So specifically, how good is this as a climate policy? I'm going to focus predominantly on one particular challenge, and it's a really big challenge, and that's the challenge of additionality. And my observation would be that additionality is a much bigger issue than people in general around this program seem to realise. And even people responsible for the program don't necessarily seem to appreciate how important it is, or even at least in one case, to understand what it implies about what the program should and should not be doing. So what is it? Additional means that the payments provided by the program cause additional adoption of these carbon sequestering practices that wouldn't happen otherwise. And that's important because only additional carbon sequestration is actually a benefit of the program. There might be other sequestration happening, but if it's not actually triggered by the payment that the program provides, then it's not a benefit of having the program. Okay, now additionality is recognised in the program, and in the Emissions Reduction Fund, there's an additionality criterion for soil carbon, and it is basically this. Were the farmers doing the practice before they signed up? If they were doing the practice before, then they can't be paid for it. If they weren't doing it before and they start doing it after they sign up to the program, then they can be paid. The exact wording in the legislation is, at least one of the land management activities is new or materially different from the land management activities conducted during the baseline period. So it's a period of 5 years before sign up that gets measured. Okay, so the problem is that criterion is not a reliable measure of additionality. Let me illustrate that by looking at no-till. The graph on the right shows how adoption of no-till progressed over time from when it first became available in the mid-70s up until about 2010. 2008 is the last year graph there. No-till is one of the items on that list of practices that farmers can adopt and be paid to do, but they would need to not have already adopted it to qualify as being additional. All right, so let's imagine we could go back in time to 1990 and that this program was in place in 1990 with all of the conditions that currently apply. What we would see in 1990, if we look at this graph, is that only 10% of about 10, 12, 15% of farmers had adopted. So 85 to 90% of farmers would not have adopted and so would have been eligible for payments under the ERF. And the problem is that almost none of those were additional. In fact, they were almost all non-additional because almost all of them were about to rush into adopting this technology. So that joining such a program at the time might have brought their adoption a bit earlier, but it wouldn't have made a material difference to the number of farmers who actually adopted. Let's look at the issue of which farmers are additional. This really helps us understand what's going on with additionality and what it really means for a program like the ERF. So here I've got, on the horizontal axis, I've got the farmer's net benefit of adoption of the carbon sequestering practice. So this is adoption of the practice, not participation in the program, adoption of the practice, separate from participation in the program. And on the vertical axis, I've got dollars. And of course, over at this end, we've got, for a particular practice, there will be some farmers for whom it's not a good thing. The benefits will fall short of the costs, and so the net benefits are negative. That's what negative means there. The benefits fall short of the costs. For some farmers, in the right circumstances, on the right soils, with the right climate, the benefits of adopting this practice could be very positive. For some, it'll be very marginal, and there's potentially farmers on all these steps in between. So I want to highlight that I'm not saying that adopting these carbon sequestering practices could not be beneficial. For some farmers, it could be highly beneficial. It'll obviously vary from farm to farm and region to region, but there's pretty good, I believe there's good potential for some of these practices to deliver real benefits to farmers. And if they do, they'd appear on this graph up this end. The issue, though, is that this is diverse. There's a diversity within the farming population about the level of the net benefits as appearing in this graph. All right, now let's suppose we bring in the carbon sequestration, the soil carbon part of the ERF, and we offer to pay farmers. I'm going to assume that there is a positive payment. Of course, it's not going to be very big given the numbers that you've seen, but we're going to focus in on those farmers. We'll assume that all the farmers on this graph would qualify to receive a positive payment, but realistically, it wouldn't be that large. So there's the offset payment that they could qualify for, the carbon credit, the value of the carbon credit that they would receive. It's small, but it's positive. So what have we got? So what this means, the way to interpret this graph is that on this side of the graph, this little gold bit slightly reduces the negative result for farmers. They used to be that bad. It used to be that bad, but now it's only that bad. For farmers at this end, it used to be this good. Now it's a bit better. And for farmers in the middle, these guys have gone from losing a little bit of money to gaining a little bit of money. So on the left here, we've got a group of farmers who I'm going to call non-adopters. They're non-adopters without the program being available to them, and they're non-adopters with the program being available to them because the benefits from the program are not sufficient to change their mind about whether it's worth adopting this practice. On the right-hand side, we've got a group of people who do adopt the practice, but they're non-additional. They were going to adopt the practice anyway because the benefits were large enough to outweigh the costs to them. Of course, they get some benefit from the program, but those payments don't actually change their behaviour. They were going to adopt anyway. It's only this small group of farmers in the middle who are the additional adopters. These are the farmers who wouldn't have adopted originally without the program, but the program provides them with a payment that's large enough to, just get them across the line so that adopting now looks good enough. Only just good enough, mind you, because the payment's small, but good enough to adopt. So those are our additional adopters. All right, so the key observation about this graph is that the availability of this payment under the ERF only triggers a few farmers to adopt. From that graph, we can tell a lot about what will happen under the soil carbon sequestration part of the ERF. What it means is that there'll be two groups of practices. For practices that are well established, so well established that their adoption has stabilised within the farming community, the non-additional farmers, the farmers who would have been non-additional, have already adopted. And so anyone who applies is probably additional, but there won't be many of them. There'll be only a few applicants who will be successful, and they will be additional. For those practices who have not yet adopted, but are attractive to adopt, so in other words, the adoption is about to grow, these are a bit like the no-till example that I showed, then the current method of measuring additionality will fail to detect these, and they'll be offered payments. So there'll actually be many successful applications to join the program, but almost all of them will be non-additional. So that's what's going to happen under the program. That's where we're heading. All of the practices will be in one of those two, all of the practices that attract payments will be in one of those two categories. And this is a problem, because what it means is that the ERF turns out, particularly for that second group, to be a very expensive way of mitigating climate change, because we make some payments that trigger changes that mitigate climate, but we make a much larger number of payments for changes that don't mitigate climate change, because those are changes that we're going to be happening anyway. In this little graph, I've got, the total payments being 6 times as big as the payments that trigger adoption. But actually, I think that realistically, it could be a much bigger ratio than that. In fact, if we did have another no-till example, I think the ratio of payments to the ones that actually trigger adoption would be something like 100 to 1. So what that means is it looks like we're paying $25 a tonne for carbon to be sequestered, but we would actually be paying $2,500 a tonne. So extremely expensive. So that answers one of my original questions. Is it a cost-effective approach? Clearly not. Now, just jumping back to the private benefits. The private benefits are important, and the private benefits loom large in many people's discussion about the practices that could sequester carbon. And many people in and around the industry talk about the benefits of sequestering carbon. And I agree, there are benefits from sequestering carbon that go beyond the payments you could get from the program. But you can see from what I've just said that doesn't necessarily mean that it's a benefit of the program itself. But there's a couple of people in particular that I'd like to quote talking about these private benefits. One is the Minister for Agriculture, who said in a recent article, the benefits for farmers go beyond carbon abatement. An increase in soil carbon improves the soil quality, stores water, and boosts productivity and yields of farmland. So it seems to me that he's not thinking about additionality there, or failing to recognise its importance. And then this other quote is from a senior executive in the Clean Energy Regulator, which is the body responsible for implementing this program. And in a recent ABC interview, she said, farmers will be getting a new revenue stream, improving the productivity of their operations, and they'll be making their land more resilient to things like drought. It really is a win-win-win opportunity. It's really quite concerning that a senior executive in the Clean Energy Regulator seems not to have recognised that a win-win-win opportunity is exactly the sort of project that their program should not be funding. It seems like they're quite okay with that sort of project being funded, judging by the tone of that comment. All right, could we fix some of this problem by having a better system for assessing additionality? Well, what that would imply is that we would need to predict individual farmers' behaviour with and without a small payment per hectare. And that means what we're trying to do is find a relatively small number of additional applicants amongst a large number of non-additional applicants, which really, I think, amounts to looking for a needle in a haystack. So my view is that there isn't really a practical solution to this problem, that it's actually impossible, given the very small size of the payments relative to the other benefits and costs of ag production. It's practically impossible to solve this additionality problem. So it gets me to the crunch. Is paying for soil carbon a good climate policy? Well, you clearly can see that I don't think it is. We've got two possible outcomes, as I've explained. For some technology, some practices will have few successful applications, so that for those practices the program will be ineffective, won't make much difference. For other practices, we will have a lot of successful applicants, but they'll be predominantly non-additional, which means that it's a very expensive way of achieving mitigation. And for that last group in particular, if the policy turns out to look successful, that's a problem. It should ring alarm bells. It almost certainly means we're paying a lot of non-additional applicants. So what should we do? Well, I actually think it's pretty clear. I think that we should shut down the program. I don't believe that the government can defend continuing with a program that has these characteristics. So my view is that the government should stop issuing contracts for soil carbon under the ERF. And if it wishes to pursue a strategy of increasing soil carbon, there's really only one serious option that it could do, and that's to change tack and approach and invest instead in trials and extension about the relevant practices to facilitate farmers adopting, motivated by private benefits. We know that private benefits are going to be the main motivation, so let's double down on that and try and make that the key driver and do things needed for that to work. They could also explore other options. One obvious one to me, is the option of trying to reduce methane emissions from livestock, which is by far and away the largest source of emissions from agriculture. As you can see on the right-hand graph, that sort of murky blue bit is emissions from livestock. And so I think an obvious thing to do would be to invest. There are some methods available. They're not all that effective yet, the ones that have sort of been accepted. There's a couple available under the Emissions Reduction Fund that farmers can be paid to adopt in the beef and dairy industry, but they're only partly effective, and I think it would be very sensible to invest in R&D to develop and prove up better methods and to promote them. Bizarrely, we were doing that. There was a program that did exactly that, a research program started in 2007. Good initial progress was made. For a short time, Australia was a world leader in this area, but then that program was cancelled by the Abbott government prior to implementation. So that was a really extraordinarily bad decision. So I think that program should be reinstated and expanded. I'm running out of time, so I'll just briefly say an interesting question out of all this that we might get to in the Q&A is, how did we get here? It seems like very odd to have a program that seems to have been so poorly thought through, seems to have so little prospects of actually succeeding in its stated goal of contributing to climate change mitigation. I don't really know the answer to this. I suspect it's a mix of misguided enthusiasm, incompetence, and political expediency. And I will leave it at that and be interested in the Q&A.